All right, folks, get ready. Today we're diving deep into an empirical study of autoregressive pre-training from videos.
Catchy title.
Right. Talk Tensors listeners, yeah, we're all about the cutting edge here. But this paper, well, this one's special.
It really is.
We're talking AI that can predict the future.
In a way, yeah.
Not like winning lottery numbers, though.
No, more like predicting the future of a video. What's going to happen next, visually?
So kind of like, what, Netflix, but for like the entire world. Instead of recommending movies, it's like understanding everything through video.
Yeah, that's a good way to put it. The paper's exploring how to train these AI models to basically predict the next visual piece of information in a sequence.
Okay, hold on. Back up a sec. You're saying it's like predicting the next word in a sentence, but with like pictures.
Exactly. They call these chunks of visual information tokens. It's like compressing a video into a language the AI can understand.
Oh, okay. Visual tokens. Got it.
Yeah.
So they trained these AI models, and how well did it actually work? Like, did they just show it a bunch of cat videos and hope for the best?
Well, not just cat videos, but yeah, the training data was massive. Over 1 trillion of these visual tokens.
1 trillion. Seriously.
Yep. From all sorts of sources like ImageNet, Kinetics, Ego4D, and How to 100MN. That's 100,000 hours of video.
100,000. Whoa. That's a lot of time watching videos, even for AI. And they actually got some, like, impressive results.
Oh, yeah. It did really well in a whole bunch of tasks. Image recognition, obviously. But also, like, recognizing actions, predicting what's going to happen next in the video, even tracking objects.
Hold on. Tracking objects. That sounds pretty intense. Like what, it could follow a tennis ball in a match or something?
Pretty much. But get this, they even used it for robotic manipulation.
Wait, robotic manipulation? So like the AI is controlling a robot arm or something based on predicting what's going to happen in the video.
Exactly. That's one of the things that makes this research so groundbreaking. It's showing that these models can go beyond just passively understanding video. They can actually start to like interact with the real world.
Wow, that's a big deal. But like, how did we even get to this point? Like, predicting the future of video seems kind of, I don't know, sci-fi-ish.
Well, it all goes back to, believe it or not, a guessing game from way back in 1951. Claude Shannon, the father of information theory, he created this game to predict the next word in a sequence.
A guessing game. That's how this all started.
Yep. And you might not realize it, but that same basic concept, that's how we train those huge language models today, like ChatGPT.
Okay, that's kind of cool. So are you saying this paper is basically applying that same word prediction idea, but to like video?
Right. It wasn't a direct jump, though. In 1954, Fred Atneve, a psychologist, he proposed applying Shannon's idea to images. Imagine scanning an image element by element and trying to predict what color comes next.
Okay, yeah, I can see that. So they're basically doing that, but with video, which is way more complex.
Exactly. It's building on decades of research and taking it to this whole new level.
Wow, it's amazing how these ideas like build on each other over time. So they've got these AI models that are predicting the future of video, but like, how does that actually work in practice? What are the nuts and bolts of it all?
Well, one of the key things they looked at in the paper was the impact of different design choices on the model's performance. A big one is the tokenizer. That's what converts the raw video frames into those visual tokens we talked about.
So the tokenizer is kind of like choosing the right language for the AI to learn from.
Yeah, that's a good way to think about it. They tried out a bunch of different tokenizers, like dVAE, that stands for denoising variational autoencoder.
Denoising variational autoencoder. Sounds complicated.
It is. They also tried VQGAN and even continuous patch normalized tokens. Turns out the dVAE tokenizer had kind of a better vocabulary that led to better overall performance.
So the tokenizer really does matter.
Interesting. What about the architecture of the model itself? Did they experiment with that too?
Oh yeah, they tried out different architectures too, like Llama, GPT-2, Mamba. Llama, that's the same architecture that's used in a lot of those big language models. Turns out that worked best for the video models too.
So it's not just about having tons of data. You need the right tools for the job. Speaking of tools, they also talked about this thing called attention pooling, right? That's how they pull out the important information from the model. Yeah, attention pooling is really interesting. Imagine you're trying to find your friend in a crowded park. Your eyes are going to naturally focus on faces, right? You're not going to be staring at the trees or the benches. Attention pooling does something similar for the model. It learns to focus on the most important parts of the video instead of treating everything equally.
So it's like helping the AI see what's actually important, not just get bogged down in the details. That's pretty cool. Any other like surprising findings?
One of the most interesting ones was that the middle layers of the model actually performed best for recognition tasks.
Wait, the middle layers. Why not the later layers? Those are the ones that have learned the most, right?
You'd think so, yeah. But it turns out the middle layers learn to represent the video information in a more, I guess you could say, abstract way. That makes them more adaptable to different tasks. The later layers, they're really good at reconstructing the original video, but they might be too specialized for just video prediction.
Huh. So it's like the middle layers have a more like general understanding of what's going on, while the later layers are focused on the really specific details.
Exactly. That's one of the things that makes this paper so exciting. It's full of these kinds of unexpected findings. And that brings us to, drumroll please.
Novel notions. Time to put on our creative hats and brainstorm some what completely out there ideas based on this paper.
Exactly. What crazy research directions could we explore now?
All right, I'm ready. Hit me with your wildest idea.
Before we get to those novel notions, though, I did want to circle back to something we talked about earlier about these video models scaling like language models do.
Oh yeah, you're saying that like making these video models bigger, giving them more data to learn from, leads to even bigger improvements in performance, just like we've seen with those giant language models.
Exactly. It's like the more they learn, the smarter they get, kind of a snowball effect. The researchers found that as they scaled up the model size and the amount of training data, it just kept getting better and better at all sorts of tasks.
So you're saying we could see like even more massive video models in the future, ones that could just blow away anything we have today.
It's definitely possible. Imagine AI systems that can understand really complex events as they're happening, in real time and predict what's going to happen next with like incredible accuracy.
It's like something straight out of a movie. But, with great power comes great responsibility, right? We got to make sure this technology is used for good.
Absolutely. Ethical considerations are super important. But for now, I want to get back to those novel notions.
Okay, yeah, let's hear them. What other crazy ideas have you come up with?
Well, we were talking about generating new video sequences based on like a text prompt. But what if we took that a step further?
How much further could we go?
What if we trained a model that could not just generate the video, but actually understand the physics of what's happening?
Hold on, you're talking about AI that could, like, understand gravity, the laws of motion. It'd be like creating a whole virtual world where AI can run experiments and learn about the real world.
Exactly. Think about the implications for, say, robotics. We could train robots to manipulate objects and navigate complex environments all within these like simulated worlds.
So we basically be showing these AI models like tons of videos of objects falling, bouncing, colliding, and they would learn like the fundamental laws of physics just by watching.
Pretty much, yeah. Of course, it'd require a ridiculous amount of data and computing power. But like we talked about earlier, those things are only getting bigger and better all the time.
Yeah, true. Okay, but this is all getting a little too sci-fi for me.
Yeah.
What about something a bit more grounded? You mentioned something about real-world applications.
Right. So imagine if we could take these video prediction models and use them to help AI systems interact with the real world, in a more intelligent and adaptable way.
Okay, I'm listening. Give me an example.
Think about self-driving cars. Right now, they rely on tons of sensors and algorithms to understand their surroundings. But what if we could give them the ability to actually predict what's going to happen next?
So, like, they could see a pedestrian about to step into the road even before they actually do it.
Exactly. They could anticipate potential hazards and make split-second decisions to avoid accidents way faster than any human could.
Okay, that's pretty impressive. But how realistic is that really? I mean, the real world is pretty unpredictable.
It's definitely a challenge. But we're already seeing huge progress in self-driving car technology. And these video prediction models could be the key to taking them to that next level, making them truly safe and reliable.
So it's not just about predicting the future, it's about knowing what to do with those predictions, making the right decisions based on what you see coming.
Right, and the potential applications go way beyond self-driving cars. Think about robots working in factories, or maybe in healthcare. AI-powered systems that can monitor patients and predict potential health problems before they even happen.
This is all pretty mind-blowing stuff, but like, hold on a sec. We got to be careful here, right? Giving AI systems this much power, there's got to be some risks involved.
Of course, we have to be super careful. One of the biggest challenges is making sure those predictions are accurate. The real world is messy, it's unpredictable. We can't have AI systems making decisions based on faulty predictions.
Now, what about like ethical considerations? We
Mhm.
don't want these systems making decisions that could harm people,
Hmm.
right?
Absolutely. That's why it's so important to have these conversations to think about the potential downsides as well as the benefits. But overall, I'm optimistic. I think these video prediction models have the potential to do a lot of good in the world.
Okay, I'm ready. Hit me with your most outlandish novel notion.
What if we combine the power of these video prediction models with, get this, brain-computer interfaces?
Oh, hold on. Brain-computer interfaces, like
Yeah.
straight out of sci-fi.
I know, right? But think about it. DCIs let people control computers with their thoughts. What if we could use those thoughts to actually influence the predictions of a video model?
So I could think about something happening, and the AI would incorporate that into its predictions.
Exactly. It'd be like a feedback loop between the human brain and the AI, working together in real time.
Okay, now that is wild. What could we even do with that kind of technology?
Oh man, the possibilities are endless. Imagine video games where you control the characters with your mind, or virtual reality experiences that respond to your emotions.
Sounds pretty amazing. But how far off is that kind of technology, really?
Well, PCI technology is still in its early stages, but it's advancing rapidly. And who knows, maybe someday we'll all be wearing DCI headsets, controlling our computers and our AI assistants with just our thoughts.
It's like something out of the Matrix. But hey, if we can predict the future of video, why not control it with our minds, right?
Exactly. It's all about pushing the boundaries of what's possible, and this research is a huge step in that direction.
This has been an incredible deep dive. We've gone from predicting the future of video to controlling it with our minds. It's a lot to take in. Any final thoughts before we wrap things up?
All right, so we've just about reached the end of our Talk Tensors deep dive. We've really gone down the rabbit hole with this one, haven't we?
We have. From AI predicting the future of video to, well, maybe even controlling it with our minds someday.
It's pretty wild to think about. But before we get too carried away, let's bring it back down to earth for a minute. You know, some of those novel notions we talked about, those are pretty far out there. They are, yeah. I mean, those are just ideas, thought experiments, really. Not necessarily predictions. But that's how innovation happens, right? You got to start with these crazy ideas and see where they lead.
Yeah, it's like we're trying to see into the future, get a glimpse of what AI might be capable of someday. And even though the picture's a little fuzzy right now, one thing's for sure, predicting the future, even in a limited way, that's a game changer.
It really is. This research is showing that AI is getting closer and closer to understanding the world the way we do.
It makes you wonder, what does it even mean to be intelligent, to understand how things work, to make decisions that shape the future? These are questions we're going to have to keep asking as AI gets more and more powerful.
Big questions for sure.
For our Talk Tensors listeners out there, if you're going to take away one thing from today's deep dive, it's this: pay attention to video prediction. This stuff has the potential to change everything.
I agree. We're talking self-driving cars, robots, healthcare, even entertainment. The possibilities are huge.
This has been a wild ride, I gotta say. I'm feeling a mix of awe and I guess a little bit of healthy nervousness about the future, but mostly I'm excited to see where this all goes.
Me too. It's an exciting time to be working in AI. And for anyone who wants to dive deeper into the technical details of this paper, don't forget to check out the link in the show notes.
All right, folks, that's all the time we have for today. But keep those brains buzzing, keep exploring, and never stop questioning the limits of what's possible. This is Talk Tensors, signing off.